NAIST began in 1991 as a new type of national university with no undergraduate programs, but with 3 graduate schools focused on advancing the information, biological, and material sciences that provide the foundation for 21st century society. NAIST uses the曼陀羅system as an information infrastructure for promoting world-class research in those 3 fields and related areas of interdisciplinary study. The name曼陀羅refers to the esoteric Buddhist belief that the search for the infinitesimal paradoxically leads to infinite proliferation. Based on the曼陀羅philosophy of attaining perfect equilibrium, the frontline staff at the Information Initiative Center are configuring the曼陀羅system as an information processing environment that meets researchers' needs. The concept for the曼陀羅system is a design built on 3 foundations, with the dynamism of walking around in nature. First is a cutting-edge research platform for information infrastructure with state-of-the-art information processing equipment. Second is high mobility, so devices can be freely used wherever information processing is required. Third is a cooperative distributed processing environment that allows users to make use of network services based on their needs. A virtual private network enables a secure connection to the曼陀羅system and VPN service for doing research and office work similar to when on campus, maintaining an environment for a smooth transition to remote work even during the COVID-19 pandemic. The曼陀羅network is the backbone of the曼陀羅system. Operation of the曼陀羅system, which unifies systems with an extensive range of functions, is dependent on smooth inter-system communications. The system also needs to support seamless resource sharing, high-definition multimedia communications, and grid computing. Ever since NAIST was founded, the曼陀羅network has been continuously upgraded to create one of the fastest ultra-high-speed campus networks in the world. Current communication speeds are 160 gigabits per second for the core network and 20 to 450 gigabits per second for branch networks. Wireless LAN services of 50 to 450 megabits per second are also available across the entire campus. The曼陀羅network ensures high-speed internet connectivity with a dedicated 10 gigabits per second connection that enables ultra-high-speed access to major websites in Japan and abroad. More than 4,000 terminals are connected to the network at any given moment. The server room in the building housing the core system for the university-wide information environment system was designed with disaster planning in mind. It can withstand heavy loads and earthquakes, and is equipped with emergency power generators. The air conditioning system is energy efficient and utilizes data from sensors that monitor temperature, humidity, electrical current, and voltage. The container-type data center houses the computing servers for the university-wide information environment system and reciprocal backup systems for other organizations. It is functionally enhanced compared to the server room in the existing building mentioned earlier. In particular, the efficiency of the air conditioning system and the center's seismic resistance are markedly superior to those of the server room in the existing building. High-performance computer server provide great versatility for handling a wide range of calculation requests, as well as enormous processing power for performing stable large-scale computing. Institute members can use this high-performance computing system free of charge. When using the system, jobs can be added to a scheduler queue suitable for the program by using virtual platforms such as Singularity, KVM, and LXC in addition to the standard method. Administrator privileges can be given to users on virtual machines, enabling a wider range of uses and support for applications. GPUs excel at processing massive amounts of data, but frequent major upgrades make staying up to date via traditional procurement and deployment a problem. This challenge is met by using Microsoft Azure and Oracle Cloud's cloud services, enabling cloud computing with virtual machines running the latest GPUs. Cloud services eliminate unnecessary costs because charges are incurred only during the time that the virtual machines are running. NAST engages in challenging research in which a car-sharing system consisting of 3 electric vehicles, established as part of the university-wide information environment system, is viewed as a proxy for society, and physical problems that arise in society are resolved using the intangible force of information. Using the miniature proxy for society established at the university as a model, research, experiments and demonstrations are conducted with the aim of achieving a sustainable society in which information technology modifies people's behavior. Able to replace electronic motors, PAMs are next-generation robot actuators that use compressed air to exert muscle-like pull force. To better work with PAMs, whose pull force tends to vary due to material degradation, experiments are performed using a system in which next-generation AI studies pull force variability by collecting empirical data in parallel from multiple robots. Research is being performed to create AI-enabled robots, much lighter than robots, that utilize electronic motors, and that also enable highly precise control. To support research in a broad range of fields, NAST uses 3D printers, offering a highly precise laminating pitch and support for different types of resin. Used for a wide range of research, 3D printers can form objects from both soft and translucent resins, as well as standard hard resins. In studies on achieving heightened virtual reality immersion, they are used to fabricate IoT devices such as sensor-equipped chopsticks or components for wearable devices that incrementally enhance the sensation of walking on the ground in conjunction with visual information. The Information Initiative Center conducts research on disaster recovery with the aim of ensuring the continuation of its operations. In light of the major disasters that have occurred in Japan since the Great East Japan earthquake struck on March 11, 2011, it is imperative that lessons be drawn from these disasters and countermeasures be taken in preparation for the anticipated damage and casualties from the huge Nankai Trough earthquake expected to occur in the near future. In the case of a major natural disaster, it is essential that disaster medical assistance teams, or DMAT, be able to share information to confirm that the transport of victims and related activities are effectively carried out. To share information in disaster-stricken areas where the communications infrastructure has been damaged, DMAT must be able to make effective use of functioning land-based and satellite communication lines. This system makes it possible to provide internet access even when the ground-based telecommunications infrastructure has been damaged by an earthquake, tsunami, or other natural disaster. This is done by connecting to communications satellites instead of ground-based communications networks, and by using the automated satellite acquisition system of a VSAT or very small aperture terminal earth station installed in hybrid cars, which provide both mobility and power. Not only can the system be intuitively operated without specialized knowledge using voice navigation and an LCD touch panel, it is also miniaturized so that it can be removed from the car for a wider range of applications in a disaster. For DMATs to function in a major natural disaster, communication between DMAT operation bases is essential. That is why NAST participated in the Kyushu, Okinawa Block DMAT field training exercises held on November 9 and 10, 2018, and in large-scale earthquake medical service drills held on September 7, 2019 that were organized by the Cabinet Office. Since 2020, we have also engaged in activities related to effective drone use in a disaster. During the Kyushu, Okinawa Block field training exercises in 2018, internet access was provided via a car-mounted satellite internet communication system using a wireless device to instantly create a single-path network between the Kagoshima Prefectural Government Office and Yanemori Hospital on November 9. Similarly, multiple wireless devices were used at 2 locations inside the DMAT Gathering Point headquarters to create a multi-path network on November 10. Wireless relays were tested using drones that enable communication in a disaster between the affected area and DMAT operation bases. During the large-scale earthquake medical service drills in 2019, internet access was provided via a car-mounted satellite internet communication system, and two types of wireless devices were used on the roofs of Yokohama City Hall and the Kanagawa Prefectural Government Office to create a multipath network for smooth communication via a video conference system between the DMED operation bases set up in both buildings. Drones are effective tools in a disaster, so it is urgent that people be trained to operate them in a disaster zone. This is why NAST collaborates with other organizations to systemize the skills necessary for drone operation in a disaster,